All right, today we're doing 6.8, and when we're done, you will be able to graph square root functions by hand without using a calculator. We're going to use the calculator to show and prove you what's happening to these graphs, but I want you to be able to do them by hand. Okay, anyone can simply type something in the calculator and let the calculator do the work, but I want your brain to be working. Okay, so today the objective is to learn how to graph radical functions. All right, this is an example of a radical function. It says y is equal to the square root of x. You are comparing two quantities, x and y. All right, this is your parent function. The graph, you're going to end up with all different kinds of equations. Here are some. Square root of x plus 5, square root of x minus 2, square root of x plus 6, square root of x minus 3. Then these are underneath the radical. Then you have numbers outside. And then you might have something like this. These are the things you're going to be able to do without using a calculator. Now, the parent function on all of this is this y equals the square root of x. All of these numbers, inside, outside, around it, they're going to change your x and y values, and I'm going to show you how these numbers affect the x and the y value. Well, what x and y value am I talking about? Well, let's establish some major points that are easy to graph. So if I look at this equation right here, y is equal to the square root of x. Can we put any negative numbers under the square root of x? Can you take the square root of negative 4?
Yeah.
No, you can't take the square root of a negative number. Can you take the square root of 0? What's the square root of 0? 0. What's the next number that you can do?
2.
Without using a calculator, I should say.
1.
1. What's the square root of 1? 1. Do you know what the square root of 2 is without a calculator? I don't. It's a decimal. What's the square root of 3? Can't do it without a calculator. How about the next one?
4.
4. What is the square root of 4? 2. Next one. Which next one can you do? 9, and what do you get? 3. What's the next one?
16 and 4.
16 and 4. What's the next one?
25 and 5.
Okay, so if I were to plot these points, what do you get? 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 2, 4, 5, 6, 7, 8, 9, and 3. What's happening after that? We're off the page. We're off the graph. Now, when you connect these dots, is it a straight line? Is this a linear function?
No.
No, this is a radical, and it looks like, reminds me of a rocket. It starts here, and it goes in this upward fashion. It's arced. Do you have a graph?
Yeah.
Okay. Okay. All right, Mr. Duke, for me, he graphed it. How do you get the graph off?
Just hit menu, and then go to the table. And it says
Okay, so here's the picture of what you just saw, and then table, Control T, Control T, and there's the table. Now let's verify that these numbers are what we have. 0, 0, 1, 1, 4, 2, and then if you arrow down, you'll see, what's the next one? 9, 3, and what's the next one?
16.
Why is this not moving? What's the next one? 16, 4, and you can keep going. All right? Now, I'm going to have you graph the next one. Oh, and by the way, let's talk about the domain and the range. The domain on this is the x values. What's the smallest x value that you see in this
Zero.
graph? 0. And what's the smallest y value?
1 or 0.
0. So your domain is all the x values greater than equal to 0. Here you go, dear. And your range is y is greater than or equal to 0. We're going to talk more about the domain and the range. I don't know why I gave you that. Domain and the range tomorrow and the next day. For now, I'm concentrating on these graphs. All right, so now, check out these two numbers right here. And then I want you to flip the page. And I want you to tell me what's different. I want you to compare. Can you tell me the difference between these equations and these? Where do you see the numbers different?
We're all under the radical dimension.
These two on the back page are under the radical. These two are out of the radical. And then if you look again at the next one, where do you see numbers?
Outside.
In front of the radical. And then you're going to be able to do inside, outside, and front. We're going to put it all together. But we're going to take baby steps right now. So I want you to look at problem 1. Okay, everybody with problem 1, there's 2 equations. Y equals the square root of x plus 2. I want you to graph this on your calculator. Oops, I got 2.
How'd you use the yellow?
Okay, what I have here, what are these 4 numbers, these 4 ordered pairs? What are they? These are the parent functions, points. These are the ones I started with, right here. I just concentrate on these 4 right here. Why am I not doing these 2? Because it's off the graph. So I'm starting here. Now I have do you have that one done?
I did 2. No, I did the second one.
Yeah, get rid of the second one. Okay, we're going to look at, this is the parent function. Okay, in the table. Here's the graph of it. And then Control T. Now let's look at these points. Instead of 0, 0, it's 0, 2. Instead of 1, 1, it's 1 what? 3.
So why do we put? Why
Yeah,
we-
why'd you break those
Yeah,
ones
what was
down?
the
I'm
point
gonna
of
show you, hang on. Instead of 4, 2, what is it? 4, 4. Instead of 9, 3, what is it? 9 what?
Using 5.
9, 5. I want you to tell me the relationship between the equation and these ordered pairs. What happened? These are the parent function points. That's that right there. The 0, 0, 1, 1, 4, 2, 9, 3 are those points. Can you tell me what this 2 did?
It took the y and added it by 2.
Yep. It took the y value and added it by 2. Does everybody understand that? So, anytime you have a number outside of the radical, you are going to add or subtract that number from the parent function of the y values. So if that holds true, without doing this, let's put the parent function in. 0, 0, 1, 1, 4, 2, 9, 3. So what I have right here is y equals the square root of x. Well, what if I wanna do -3? What do you think you're gonna do to these y values?
Minus 30.
So what would I have here? Instead of 0, 0, I have 0,
-3.
-3. Instead of 1, 1, what am I gonna have?
-2.
Instead of 4, 2, what am I gonna have?
-1.
-1. And instead of 9, 3, what am I gonna have?
-0.
So, let's, Mr. Duke, do you have it? Thank you. He plotted it. And let's see if we're right, if our prediction holds true. He graphed it for me, and guess what?
Okay.
So far, 0, -3,
I see.
1, -2, 4, -1, and was 9, 0 there?
Yep.
Yeah.
So, look at these. What do you think this 5 is gonna do? You're gonna add 5 to the y values. You're gonna subtract 2 from the y values. You're gonna add 6 to the y values. You're going to add, subtract 3 to the y values. These numbers outside are gonna move your graph up and down. They shift your graph vertically. It's a vertical shift. This is gonna shift your graph up 2, and this one is gonna be down 3. So when I say it's gonna shift this parent function, here's the parent function. And I'm just gonna do these 3 points, just to make it quick. So that's the parent function. This is y equals the square root of x. So if I wanted to do up to, it's these points. All it did was, this is the graph, y equals root x plus 2. And where is root x minus 3? It's 3 down. And right there. So this is y equals root x minus 3. So does everyone have this operation down? If you see a number outside of the radical, you're going to add or subtract that same number from the y values. Y values. Okay, now flip it over. This one's a little tricky. These two numbers, does everybody see, are underneath the radical as opposed to outside of the radical. You have to see the difference. So now, if we took these ordered pairs, which ordered pairs are these? Where are these coming from? The parent function. This is from this, right here. Okay, so we're going to take both of these. And Mr. Duke, do you have this graph yet? Okay. He just put in his calculator y equals the square root of x minus 3. And let's look at our points. We now have, 3, 0. We have 3, 0. And then we have 4, 1. And then we have, what's the next one? 7, 2. Yeah. And we have 12, 3. So what happened? What did that number underneath the radical do to my x values? What did we do to all of these x values? We added 3. You are going to do the opposite of what this is. We added 3, not subtracted 3. This is going to shift your graph 3 units horizontally to the right. So everybody check this out. The number underneath the radical moved your graph left or right. You're going to add 3. This added 3 to your x values. What do you think this is going to do? Let's predict it and then let's graph it.
Subtract 2.
You're going to subtract 2. So 0 minus 2,
Negative 2.
-2. What's this one going to be? -1. What's this one going to be? 4 minus 2 and 7. Mr.
Wait,
Duke.
why is it, why are you minus
It,
Oh, you minus
it,
the plus.
see how it did the opposite?
Oh.
It changes it.
Okay.
That one changes it. Okay, so he graphed it for me. and let's verify. He's got -2, 0. He's got -1, 1. He's got 2, 2. And he's got 7, 3. Amazing.
Wait, what?
What's your question?
I'm just confused how it's supposed to, how did it just do that?
The number underneath the graph shifts it horizontally the opposite direction, whatever that number is. So -3 is gonna shift it right 3. The +2 is gonna shift it left 2, and he's got the graph right here. So this one shifted, even though it said, this one is +2, it shifted it 2 to the left. If it says -3, it's gonna shift it 3 to the right. Okay, next 2. This one has numbers in front of your x. So I want to take your parent function again. You're going to get really good at this parent function. Oops. Okay, Mr. Duke, what do you got? Y equals 3 root x. And I'll tell you what he's got. He's got 0, 0 still. He's got a 3 here. He's got a 6 here. And he's got a 9 here. What happened? And let's verify it. 0, 0, 1, 3, 4, 6. And we've got 9. 9, 9. These are all, I didn't make this up. He plugged it in. He plugged the equation in.
You just multiply it by 3.
There you go. So this number outside multiplies the y value by that number, whatever it is. So what do you think this 1/2 is going to do? So let's take 0, 0,
Multiply
Divided by
x.
not x.
Divided by
The
2.
number in front multiplied the y value by that number. So what do you think 1/2 is going to do?
Multiply.
The y.
You're going to multiply the y values by 1/2. So you get 1/2. I'm sorry, 0. Went too fast. 1/2. 2 times 1/2 is 1, and 3 times 1/2 is 3/2. Mr. Duke, do you have it? Okay, let's verify if this happened. 0, 0, 1.5, amazing. 4, 1, and 9, 1.5. So, let's put it all together. Let's put it all together. What did the number outside here do? We added or subtracted that number to the y value. What did the number inside do? We added the opposite to the x value. So this one you'd add 2 to the x value. Subtract 5 from the x. Add 4. A number in front multiplied the y value. And now what if we do a combo? This is what you're going to do. You have to do the change on all of them. This changes your x value, this changes your y value, and this changes your y value. So these two numbers outside affect the y value. And I just showed you one at a time why. The number underneath here affects the x value. Now, when you get to higher math, I'm just going to show you something. You might see something like when you get to pre-calc, because I do teach that. You're going to see a number in front of the x here. This number, what you would have to do, and you're not responsible, this might be an extra credit problem. Okay. These two numbers change your x values, and these two numbers change your y values. We are not concentrating on this. We're doing in this class this change, and then these two. In the order you're going to do it, you're going to do this first, then this, and then this at the end. So first, you're gonna do any change in your x value. Then you're gonna multiply the y value by that number, and then you're gonna add or subtract that y value. So the y value gets hit twice. The x value is gonna be hit once. So let's put it all together. Okay, Mr. Duke, I want you to do that in your calculator while we do it by hand. So I want you to start off, see this little box is your parent function. I want you to start with, give me 4 good points.
0,
1, 1, 4, 2, 9, 3. We start, this is our start position. So now, this is our first operation right here. We do this first. We are gonna take our x values and subtract 2. What x values am I talking about? These x values. So can you tell me what my new x values are gonna be? If you took this and subtracted 2.
-2, -1, 2, 7.
And now keep your y's the same. So that's step 1. This is the first thing you're gonna do. You're gonna add the opposite of this number to your x values. Now you're gonna go here. See this 3?
You multiply by 3.
Your y, you're gonna
Y.
take your y values and multiply them by 3. What y values am I talking about? These ones. Multiply these all by 3. You get 0, 3, come on,
6,
6, and 9. Keep these the same. We're done with the x's. That's a 7. Okay, so we started off by subtracting 2 from our x values. Then we multiplied our y values by 3. And the last thing you're gonna do, this is y, and this is second in line, and this is the last
So you
thing.
add 4.
You're gonna not add 4, subtract 4.
Oh, I thought you do the opposite.
No, the only one you do the opposite is the one that's this underneath here.
For the x values, you do the opposite. Y values.
So you're gonna take your x values and keep them the same,
We just said why.
and we're gonna subtract 4. So what's 0 minus 4?
Going too fast.
I'm going too fast? Okay. The reason I'm going fast is because of blending. How much time do we have?
About 12.
Okay.
So you subtract 4 from 0, so that's where you get -4.
Yeah,
Alright,
yeah. Subtract 4 from 3, what do you get?
-1.
Subtract 4 from 6 minus 4 is, and 9 minus 4 is 5. Now let's plot these points. -2, -4. 2, 1, 2, 3, 4.
That's what confused me.
What?
That last, like how you like do the negative and the positive. It's like,
The points?
oh, yeah.
You have to do it in order. You do the opposite of this. The reason why is because I showed you up here. This is what this did. It moved your x values opposite.
How come you don't do the opposite of the y?
It just doesn't work that way. This shifts your graph horizontally, the opposite direction. So this one is gonna be -1, -1, and 2, 2, and 7, 5, 2, 3,
What about the one, or negative one is?
-1 is right there. Then 2, 2, and then 2, 3, 4, 5, 6, 7, 1, 2, 3, 5. So it looks like this.
Aren't you subtracting it?
Yeah,
On that one?
6 minus 4 is 2,
Are you using the 6 from there?
because that's the y value.
Oh, okay.
You take the y values and subtract 4. Let's get these new y values. Okay, now, Mr. Duke, did we do it right? Okay, so, he graphed it, that's his graph right there, and here's his table. Let's see if the table matches our table. Wow, we have -2, -4. We have -1, -1. We have 2, 2. And we have 7, 5. You get this? Now, we're gonna do this for 3 days.
Why did I get 7-3?
3 days. So I want you to flip this over. Let's
We have
see.
a test on this too.
You're gonna have a test on everything. And I'm telling you, the more you do, the better you will get at this. The more you do, the better you will get at this. So here's your first problem. Now, are there gonna be 3 changes on this one?
No, just two.
Just 2, good job.
But what-
Why just 2?
Because there's not a number outside on the,
Perfect. There's 2 changes.
So do
There's
we-
a -3 and a +2. So what are you gonna do
do
first?
we need all the tables in?
No, you don't need all the tables, but I just put them all in for, I put all 4 columns in.
Right parent for the first part.
Right parent, so what is your parent? Let's do it.
And you put X, Y, and you do 0,
0, 0, 1, 1, 4, 2, and you don't even, just do not up to 9, 3. You don't even have to do this last one. You don't have to, it's optional. You wanna try it and see if you can get it, it would be what? 16, 4 if you wanted to do it. Okay, step 1, see this number right here, it says -3.
So you add 3.
You're gonna take your X values and you're gonna add 3 to them. So tell me what you get.
Yeah, 3, 4, 7, 12. And then Y stay the same.
And the Y stayed the same, so we did step 1. Now, what are you gonna do with this 2?
You add 2.
Yep, add 2. Now, I like to put my finger over so I don't get myself confused. I'm gonna add 2 to all these Y values.
2, 3, 4, and 5.
2, 3, 4, and 5. What do I do with my X's? Keep them the same.
And that's it.
So, that's it. Plot these points right here. Plot 3, 2. Plot 4, 3. Plot 7, 4. 7, 8, 9, 10, 11, 12. And it should be an arc. Now, Mr. Duke, do you have this one? Let's verify. Did anyone verify? Travis?
Yeah.
It worked?
Yeah.
Okay. Number 2. Oh, here it is. We got it. Let's verify it. So, our first point was 3, 2. Guess what? We have 3, 2. We have 4, 3.
What's the homework?
We're doing it. 7, 4. And 12, 5. Okay. This is your homework. I want you to do problem 2 and 3. Can you do that?
Yeah.
Now, on the back are 3 more. It's up to you if you want to save them for tomorrow. Kind of want to go over them again tomorrow, but we're going to do more tomorrow. But can you just do 2 problems for me today?
Yeah.
Okay, thank you, Travis.
Yeah.